this time. So, all right, so let's just download this. So this is our data set, right? The Sol bike data. And we have it as a list of dictionaries, right? That's this bike hours. And we like kind of the typical thing is select the first one and then look to see what are the attributes, right? This is the dict keys object. So we select the first record dictionary, call.keys, and then we can just see, okay, what are the attributes that we have available for us? Why do we do that? Well, it gets us a sense of, like, as we said, like, what is the grain of the data? Meaning, what do each one of these records represent? So in this case, it's for a date, for a given hour, how many bikes are rented, right? And then you also have these other characteristics, like the weather, etc. Then we had this from the last part, or no, I think I did this for you, which is also pretty typical, right? We start with a lot of different attributes, but we only need a subset of them, okay? So it's a good idea to, what we'll call, like, reduce the data, okay, to make it easier for ourselves. So here we go through each one of the dictionaries. Then for each dictionary, go through their key value pairs. If the key is in the specified attributes that we want, append the key value pair to the list. This thing we should start to see as a dictionary, right? Because it's a list of tuples, and then we coerce that to a dictionary down here. Okay? Go through each dictionary. For each dictionary, go through the list of tuples, right? The key value pairs. If the key is in our specified attributes, then append the key value to this list of tuples, turn that into a dictionary, right? And now this is now a smaller, if you look at maybe just one of them, right? This is more manageable than what we started off with. And I'm calling it, right, selected bike hours as opposed to the original. So you can see that how much, right, this is a good bit larger. So then the next thing, right, is what we did not add in here was the date. And that's because we wanted to coerce the date, right, so that it's year, month, day. And we wrote in the previous section, we wrote some code for that. So we'll just use that. And now let's see if I can write it. Otherwise, if I can, I have the answer below. So what we want to do is take these bike hours and then take the date, the formatted dates, and basically pair them together. Let's just do list so we can see it. And we'll call this my paired data just for now, or paired hours, dates. And let's take a look. Okay, so here's the dictionary. So it's a tuple, right? So one thing just to point out, when you're looking through your data, I recommend just focus on the edges of the data. What I mean is, by looking just at these three characters, it's telling me, okay, I have a list of something. The parentheses says it's probably a list of tuples, right? So it's a list of tuples where each tuple consists of a dictionary, and then down here I can see the other element is a string. Okay? So I'm starting by just identifying what does this data consist of. The other thing you can, of course, do is, again, look at the first element. First element is a tuple by looking at the edges of it. So this is the list. Then we have a tuple. Then, again, I'm looking at the edge, dictionary, string. All right? Okay. So for each one of these, we should for our comma date in this list, right? We'll unpack it, and then we will assign, right? Take the hour. We should call this the selected hour. Take the selected hour, add in a key of formatted date, and then assign it to this. I should call this actually formatted date as well. Assign this to be the formatted date. And let's see if it works. So we'll take the selected bike hours. Beautiful. All right, so it is there. If you're actually, I think it's a valid complaint is that it doesn't follow the same pattern as everything else. So we could start over and change it, but that's probably what we, like in real production code, we should do that. We want a capital here, is what I'm saying. Otherwise, this works, okay? Just to spend a moment on why this works. We go through each one of these byte hours, and here we actually alter the data, okay? So when we go back to this original list up here, each one of the elements inside of it is changed, okay? This works. It's fine, like for you all to do. I do want to spend a moment on it because it is a bit of an anti-pattern. So let me just show you maybe why. So let's say we have a dictionary. Let's call this like my person. This will be Bart. So this will be first name, Bart. Right, last name, Simpson. And then let's say for I in range 4, we will give ourselves Bart. And these will be my Barts. Okay, so we have all these guys. Now, if I change one of them, where I assign the age to equal 8, let's change Bart to equal age 8. And now I look at Bart's again. So, right, they've all been updated. So this is weird. It's not weird. It makes sense, right? What we just did is we defined this object. We are placing, and this is just a pointer to a dictionary in memory. So imagine that this dictionary gets, an allocation, right? It's basically a memory address. So let's say it's like address number 108, right? And when you go to address number 108, you see this dictionary. You open up this mailbox, you get this dictionary. Now we are placing, a reference to this location 4 times, okay? Then we are updating, right? We go to the mailbox and we add a new key value pair. So when this list looks at the reference to this location, all of them are updated, okay, forever. So this can be problematic because it's like down here in your code you make this change, and up here in your code, right, it looks like the data's here, but then you didn't realize that somewhere later in your code it's actually been updated. You get what I mean? So the point is, changing your data, I know it might feel weird because it seems like we do this a lot, but we don't. This is our first time changing a dictionary. And changing the data can be problematic because it can, it's like at one place it looks like one thing, at another place it looks like another thing. So how else can we do something like this? Instead, let's try this again. You have Bart, and then let's say we do for I in range 4. We will take Bart, and instead what we'll do, I'll just show you this quickly, is we'll do Bart.copy. Okay? And this will be my new Bart. Okay? So now, if I do new Bart age, or let's do something else, let's do hometown, is Springfield. Okay? Now new Bart, this is a clone, right? So new Bart has Springfield in it, but old Bart is left unchanged. Okay? So this is the preferred way to do it. It is make a copy of your data, change the copy. Leave the original untouched. Why? Because if you ever want to go backwards, but really not even that. It's more because it's confusing. It's confusing for it to be one thing in one place and another thing in a different place, right? And oftentimes when your code base gets large, when we get to functions, you can just call a function. That function can affect this data, and all of a sudden this data looks different. So that's what we want to try to avoid. Bart points to one, let me just read this question. Bart points to one memory location. Let's take a look. So Bart points to one memory location. Let's say it points to 103. the list comprehension must have created copies. So why 8? Okay, it does not. So Connell was saying, hey, the list comprehension, when we do this, must have created copies. So how come when we update it, are all of these changed? And the answer is it does not create copies. This part right here is not creating a copy. Only when we do something like bart.copy is it a copy. So let's just see this again. So we have this dictionary. Let's say, for example, it's in memory location 108. We are not creating a new instance of Bart here, right? You can kind of tell, because how do you create a new dictionary? Either you do this, dict parentheses, or you do the squiggly brackets. Those are the two ways. I mean, there's like, a couple other ways, but this is not one of them. This created a dictionary one time, and then for each time, 0 to 3, we are appending the same dictionary to the list. This is all at the same spot. So when this guy is updated, and I do Bart, hometown, let's just say Philadelphia. All these get updated. Wait, did I lie? Here's Bart. For each one, we do this, Bart Simpson. Here's my Bart, 4 by, set the hometown. Now I'm confusing myself. Have the Bart in here. We just saw it.
I think you run bots after you modify.
Oh, true. Thank you. Yeah, I declared it again right here. So thanks. So let's do this. And now I'm going to uncomment this line so I don't do you guys get what was going on? I did assign it, but then when I press shift return again, I reassigned the variable to equal this dictionary. So now we can just do it in 3 steps. We'll say Bart equals this. So Bart points to some location in memory, say 108. Then we go through the loop, and this is the same Bart Simpson, all pointing to the same guy. This is just a pointer, right, to this mailbox. Then we update Bart. So we just updated the same guy, and now we'll do it again. Okay.
Is it safe to say this list created over here it actually contains references to the Bart dictionary? And
to the same Bart. It contains the same reference. Each one of these is the reference to the same same location in memory or the same data.
And if we added the age using the Bart's using the Bart's variable, like Bart's 0, age equal to something.
Oh, that will okay. Even good question. Let's do that. Just to really prove this works. So here we have our list of dictionaries. Now we'll do Bart's 0, and let's say Bart's 0 is this first one, right? And now we'll do Bart's 0 square bracket age, right? So I'm going to add we select this dictionary, and now we add a new key value pair, let's say of 12. Now let's look at the whole list of Barts. They all get 12, right? Why? Because really each element here is pointing to the same piece of data. So you can see how while, this is like 5 lines of code and it can get confusing. So we try to make our lives less confusing. So instead what you can do is declare Bart and copy it each time. Now, if I update one of them, let's do Bart's square bracket 0, square bracket age equals 12. And now we take a look at it, only the first one, okay? What's a way to check this? What's another way to kind of check this? You can go through each of the, each guy here for Bart in Bart's, ask for the ID, okay? If they have the same ID, they are the same they live in the same memory address. Here they have different IDs, okay? So different memory addresses. If we didn't do this Bart.copy, let's take a look what happens. Same memory address. Okay? So why do I say this? How did this come up? Here we're changing our original data. Bad news, okay, right? Like, especially with dictionaries, because like dictionaries, when we try to access a key that doesn't exist, it breaks, like, all right, we get that key error thing. So what should we do instead? We should say, let's download our data. So we'll re-download our data. Okay, we have our formatted dates thing. Okay, and now this time what we'll do, we'll go through each one of this our original data set, and instead of updating it, we will make a copy. Okay, call this selected hour copy, and now alter the selected hour copy. At this point, the original list of selected hours is unchanged, right? Because I did not update any of those records. I copied it and then assigned the copy to this variable and then updated the copy. So now what should I do? I should call this, have a list of selected hours with dates or something, whatever I want to call this. Add it to a list and then do selected hours dates.append the copy. Okay, and then we can look to see, hopefully, that the date is here. But if I look at my original, I think it's called selected hours. Selected bike hours. If you look at the original, this is unchanged. All right, this is what we want. Okay. Right? It means that like when I go back up to the top, I don't have to worry that some later part of my code altered this data. So, in our methods that we've been using so far, it's just naturally like every time you do a list comprehension, that creates a new list, right? As long as we're not altering a dictionary, like we're kind of okay. So far this is the one part that we ran into some like dangerous kind of like anti-pattern. So I wanted to point it out that the best thing to do is not to alter your original, but rather make a copy of it, update the copy, add the copy to the list, leave the original unchanged. All right, we got a couple questions. Okay. Will this behavior be the same for other data structures like a list, set, etc., as the variables also contain references? Well, lots of times, this is where it does make sense to know. You just want to pay attention to when you are altering something, right? So if you have for example, if we have a list of names, right? Bart, Lisa, Maggie, and then we say, okay, for a name in names, we do name.capitalize, right? Just know that this is producing, right? This is producing a new list. So we're not altering anything here. What is a little dangerous, maybe? This is kind of you can worry about this a little bit later on in life, but like appending. But it's really appending. We have to talk more about functions to really start to worry about this, because you can append stuff. Just you want to do it like inside the same function. Anyway, so just know like Python is kind of helping you, because you're not changing the original list here. You're creating a new one, right? Same thing like when we do. Sets actually, I don't know, can you even add? I don't think sets are mutable to begin with, right? So like if you have a set, let's do set of names, right? And these are unique names, right? You can't append to it anyway. So it's only really lists, dictionaries, even strings. I'll show you that in a second. So let's append Marge, right? You can't alter this guy. Maybe you can do pop. Can you do pop? Yeah, so we can pop it, I guess, but we can't add to it. Strings are also immutable, meaning that you cannot change a string. So if you have, let's say the name equals Bart, right? And then we do name add in, Simpson, and let's say, right? That's creating a new string right here. The original is unchanged. All right? And again, the way to check for this is just assign it to a variable and then compare the IDs. So here it's 608, and then if you look at this guy, it's totally different. Okay, so Python is helping you out a lot by, in a lot of cases, by making a copy of this and then, or creating a new string for you, and combining these, list comprehensions, or creating a new list for you, those types of things. Set has the add method. Oh, thank you, Miles. That's probably true. Let's take a look. Unique names dot add. Yep, there you go. So add March. Yeah, so we can change our sets, it looks like. Cool. We can add or remove an item in the set, but we cannot modify. Oh, we can't modify an item in the set. Okay, cool. All right, so I just wanted to go on that. Tell you that because this, not only because it's good to know in the long run, but also I've seen it throw people off early on, get very confusing even at this stage of the course, and it's because you're doing something that is because altering a dictionary can kind of bite you. It can, even with a little bit of code, it can start to get confusing. Okay, so that's mainly what I wanted to talk about. In terms of using the zip, just just think about what you want to do without code. You want to go through each one of these dictionaries along with its corresponding date and then pair them together, right? That's what you want to do. So zip is a good tool for that, right? So that's how that should be the clue to use zip. All right.
Pulling data from somewhere. And you have written 3 lines of code there. So you can write a function, define a function which is pull data and put those 3 lines in there. So you can keep calling it. So this is what the basic structure of a function looks like. So you have this is the definition. So you use def to define it. And then you have the body of the function, and then you may or may not return something. And the other thing is you might have something inside the brackets, or you might not have something. Those are called parameters or arguments. Like I was saying, you might have a return value or not. For example, this is a function that I've defined. It's called greet, and what it's doing is basically it's printing. So there is no return value. Let me see. Yeah. So now if I just run this function, and this is how you're going to run this function. Once you define the function, you're going to call the function with the brackets, the round brackets, and it's going to print something. In here, I didn't return anything. So when you call the function, what it does is it goes and runs the code inside it. So it's printing something in here. Let's define a function which has the parameters or the arguments that I was talking about. So in this function, it's called add strings. And what we have is we have defined first string and second string. So we want these 2 arguments, and what we're doing is we're concatenating them. So we are putting the first string, then we are putting a space between, and then we're putting the second string. That's what this is supposed to do. And this is what is returned. So let me run this. And then I can say something like underscore strings. And then I can pass in hello. So it returns the first string with the space and then the second string, and that's what is getting printed here. The other thing I could have done is I could have just printed it in here and not return anything. So if I do that, let me do that. So this is the definition of the function. It does the same thing. So sometimes you need to return something, sometimes you do not. So and the other thing is like sometimes you need to pass in parameters, sometimes you do not.
Do you mind, Apurva, can you just try to assign the result of add strings to a variable, like to maybe call it greeting or something? Yeah, that works. And then let's take a look.
But I'm printing it.
Exactly.
Yes.
So I just want to. Yeah, no, that's good. I just want to show. Keep it as it was. I just want to show. My apologies. Yeah, just keep it as print. Okay, cool. And now let's take a look at what reading is.
Let me just add underneath.
Exactly.
So the reading is empty because it's not returning anything. So nothing is getting assigned to reading. But within the function, like it's printing something. So if we would have done something like, if we would have returned this. Yeah, let's just return. Does this make sense? Because so what's happening right now is we have defined the function with the return. So it's returning the string. And when we call this function, we assign the returned value to the variable called reading. And now we are printing the reading. That's why you see hello everyone printed out. Earlier, what was happening was we had the print statement inside the function, and it wasn't returning anything. That's why reading was empty. Okay, so when we define these arguments, for example, the add strings function, it has the arguments first string and the second string. What happens there is if I want to call add strings now, and I just pass in one argument, it's going to error out. It's going to be like, where is the other one? We need the other positional argument. You didn't pass that in. When you define a function with arguments, you need to make sure you pass in all the arguments, or you give a default value to another argument so that it'll use the default when it's not passed in. For example, I can give a default of world to the second argument. And now if we try running this, it would run. So since it didn't get the second argument, it just took the default value of the second argument. It just put that in there. So you can do the same thing. Like I can do the same thing with the first string or the second string. But now if I don't even pass in the first string, it would again give you the error. Because the first string doesn't have the default value. So you need to make sure like when you have arguments, you pass in all the arguments. And if you're not going to pass in all the arguments, you give the default values in there. Okay, so that was about the default value. And the last thing I want to cover is there's something called pass. So when you define a function, for example, reading, and I define the function. Now I don't know what I'm going to put in there. And I'm writing my whole code. And I just say, okay, this is it. I'm going to come back and work on this. And I do this. It's going to say it's incomplete. But what I can do is, if I write pass in there, it's going to let it be like that. I can come in and like change or put something in there. So if you want to define an empty function, you need to like work. You need to define this. You can keep it with the pass in there, and it would work. Are there any questions? I cannot see the chat.
I do want to show just one gotcha because I see this happen all the time. It is kind of like confusing, I think. So I'm going to open up a notebook for a second. So one thing just to pay attention to is like, let's say we define a function, like add numbers, right? And then we do, it wouldn't even need an argument. Let's just say add ones. And then we'll just do 1 + 1. Right, so obviously as we know, right, right? If we execute the function, but we forget the return value, right? Nothing's going to get returned, so we fix it, right? So that's kind of one thing. The other thing, one thing that I often see occur is like you'll do something like this. You say, okay, let's try out our function, and you do add ones, and now you see this kind of thing, right? And it's like, what is this? What you're seeing in Python, this thing exists in just the same way a list exists in memory somewhere. This function, right, exists in memory somewhere, and you are like referencing the definition of the function, but you're not executing the function. In order to execute the function, right, you need the little parentheses. Okay? So this you basically only do when you're making a mistake. There's not really a use case for this for you all. But you will make the mistake, and you'll see something like this, and just know, okay, you just pointed to the function object, but you did not call the function in Python. All right, makes
A
sense?
quick question from this one, the reference you gave regarding articles without the parentheses. Can we send this as an argument to another function?
You can.
To be called inside?
Yes, you can do that type of thing. Yeah, and that exists in languages like Python, JavaScript is pretty popular as well. Just like a similar example to this to show you. Yeah, let's do a list. 1, 2, 3. These are my elements. Right? What am I doing when I do elements.pop? Right? I'm calling a function. So if I forget to put the little parentheses, right? I'm showing that function like object, basically, but I'm not executing it because I forgot the parentheses. So if you want to execute it, right? This is, it does actually two things. One, it removes the value, and then two, it gives, what's the return value? Well, whatever I got back, right? 3. The return value is the value that was just removed, right? And now we have this. So it's an interesting thing, like when you're going through functions, to like try to think of, when you're calling predefined functions, to think about, okay, what is like the return value and what are they doing? I wonder what is it with the question? It's with a question mark, right? Where you can, in Colab or Jupyter, put the question mark beforehand, and then you can see this. And right here, it's talking about like the signature of the function, and there, right? This is kind of interesting, right? It's defined with the default argument, right? Index equals -1. Here it tells me what it does, right? And it tells me like, I guess it has this error. I thought it might tell me the return value, but it didn't. But that would be a nice thing for it to do. All right. So when you think of a function, like when you think of like both, I guess, the functions that you write and the functions that are there for you, you can think of what's called like the signature of the function, which is basically the name of the function, the arguments it takes, and the return value. Okay? So same thing here. It's like elements.pop. What arguments does it take? Well, it just tells you, actually. It takes an index. So why do we not know that? Because it has a default argument of -1, which we want, which sounds good to us, right? Remove the last element, -1. But it seems like if we want to, we could also remove the first element, right? Because it's a default argument. Cool. All right. Cool. So we have like 15 minutes left.